All right, so we're going to look at the infrared thermometers. Specifically, we're going to look at the infrared thermometer, which is just the brand that we have. They all work generally the same. I like this one because it has two lasers on it so that you can make sure that your distance is pretty accurate whenever you are trying to use it. So with that, we'll move through and look at infrared thermometers. So in the box is super exciting. You're either going to get one in the box, the infrared one is this blue one here. It does come with a 9-volt battery and just a little bag that you can put it in. So pretty straightforward when it comes down to dealing with what you're going to get. I'm going to turn my little laser pointer on here. Woohoo! So basically these three things. So you're either going to get this or it's going to come in the box. No big deal. When you do get it, if you don't have the battery installed, I may just go ahead and install these because it's easier. You need a small screwdriver. It's actually a little bitty small one, or at least one's got a good point, to unscrew the battery case so that you can then put in a 9-volt battery. Pretty straightforward. Close the case back up. I used a little eyeglass um, Phillips head screwdriver to get it to work, but you can use whatever you want. So powering the bad boy up is going to be useful. Another thing of note is you can actually see that it has a mount for a tripod, which you'll have, or so for any camera mount, this will work on it as well. So you can actually mount these if you really need to. So when you get it, if it's not off, there's a little film on the outside. So go ahead and take that little film off, so that it's unnecessary. It's just a screen protector. So when you first turn a little bad boy on, so I just pulled the trigger there, you can see that if it says scan in the top corner, that means the trigger is pulled. That means you're actively trying to find temperatures. So you want to only pull the trigger when you're at the right distance. The laser will come on. You can actually check it. This E right there, E equals 0.95. You're probably going to get that pretty systematic. You can adjust this as necessary. This is the emissivity. So the emissivity is basically how well that surface is shooting back information. Always make sure that your data are in Celsius. Here's a light. You can turn the light on and off with the light. You can turn the laser on and off, but we'll go through the buttons here in a sec. So here's just a landing screen right there. Basically, if you got scan, that means you're actively getting data. Here's the data that it's being recorded in front of it. And then your emissivity up here that can be adjusted. You're not going to worry about it too much here. Just make sure that you're in Celsius because we're doing everything in science. So the IR thermometer has basically two lasers. So if you're really close to the object, they'll be far apart. When you get up to one dot, this is almost perfect there. There'll just be one dot on the table. That means the two dots are pointing at the same thing. And if you get further apart, they start spreading apart again. So the cool thing about the infrared thermometer that has two lasers is that you can be consistent every time that you're distance away from the item that you're trying to measure. Usually that's about 18 to 24 inches away, so about 2 feet away from the object. They're all slightly different, but roughly if you got to shoot for one, if only got one laser on it, try to stay consistent in how far you're measuring, because if you're too close to it or too far away from it, you're going to get a different reading than if you're being consistent. And the whole point of science is to be able to replicate what you're doing. So it does come with a user manual. This is just a picture of the user manual, as exciting as it is. You can look through that and see all the various details, but I'll show you the big things that we're going to be doing. So the first one is you have the screen here. So you can see it says hold. That means that the trigger is not pulled. We're done. And so it's not bringing in any more data. It's going to keep this data up there for about 30 seconds or so. So you need to pay attention to your data and write it down as quickly as you can. Here, the last reading that I had was 27.3 degrees Celsius. And we can see that our emissivity is again at 0.95. The light is on, backlight is on. We were looking for the maximum temperature down here. So the maximum temperature here recorded at 96.5 degrees Celsius. Yeah, that's crazy hot. Boiling is 100 degrees. That's because I scanned I had a burner on a range on, and I turned it off to see that I would get a high temperature. So as you scroll through your mode, you're going to change what you're looking at. So once you get your data up there, you can hit there for Celsius or for Fahrenheit. The up-down buttons are you can put alarms on it. We're not going to worry about the alarms. Pretty straightforward stuff there. So really just going to mode through there. So the first one we're looking at is the maximum temperature during the scan that I just took was 96.5 degrees. Here we've actually, looked at now we're looking at the minimum temperature. So minimum's over here. So max was there, bounced over to minimum. The minimum temperature that I recorded was 22.1 during the entire time that I held down my trigger. So I can actually scan an entire surface looking for highs and lows on a surface as opposed to just a single trigger pull and get a number. Here we're looking at the average temperature, so it takes the maximum minimum and divides it by 2. So the average temperature was 59.3, which is crazy hot in Celsius, but it's because I scanned a burner, if you recall. So we basically went from a very hot burner that you're boiling water with to the temperature of the, the, the countertop right next to it. And then it will even tell you what the difference is. So that's basically the maximum and the minimum based on what was the highest temperature and lowest temperature. So these things can all be useful in trying to figure out when you're scanning, a surface, or if you're scanning the inside of your birdhouse, or if you're scanning anything, along your skin or something like that. You can find the high temperature, low temperature, what the difference is along that particular surface. So the way that these things work, it's a relatively straightforward device. You pull the trigger, you're going to get energy coming back into the sensor. So um, basically, this is a passive sensor. It's not sending out energy. Like, if you look at night vision, usually sends out a signal that then bounces back. This one's just pulling information that's coming off of it, off of a distance. So everything is a radiating body. If it's above, absolute zero, it's going to be radiating energy off of it. But the mistakes that we get from collecting that information is that what we want is the emitted energy from the surface. So this is infrared thermometers measuring surface temperatures. But we also have transmitted energy that can be coming from the center of the object or even theoretically pass through the object. And that will give you a false reading because you're getting extra energy being added in. We also have an issue with reflected energy, and this can become off of other warm bodies, but the sun is the most common one, bouncing off the building. You're also catching the energy from there. So you want to try to make sure that you're trying to shade the object if you can. It depends on where you're trying to read it, but those are the most common problems. The other ones are going to be too far, too close. That's why we use the two lasers. If you use the two lasers, you're getting a single dot for where your target is. That's going to help you out quite a bit. So really it's about getting extra information that's transmitted energy and reflected energy as opposed to just emitted energy. The other thing is we want to try to scan it at 90 degrees off the surface to try to eliminate as much of the reflected energy as possible. We want to see what energy is coming directly off, so not shooting it at an angle because that radiating energy could be coming off a different direction. So we want to try to be consistent in our measurement. Really quickly and how it works, it's pretty straightforward. The IR thermometer kind of sees, if you will, energy coming off. It's in the infrared spectrum. So if you think of the colors of the rainbow, the human have a visible bandwidth. It's the Roy G. Biv red, orange, yellow, blue, indigo, violet. So the colors of the rainbow. But infrared is a frequency that's even slower or lower frequency than even the human eye can see. So we're using a sensor to see what um, the humans can't see, so we're going to shift it. So it basically has what's called a thermopile. The thermopile is what absorbs energy and reacts to the infrared spectrum. The lens focuses on that thermopile and then records that on a scale that we can then understand. We can use Celsius or Fahrenheit. We want to use Celsius. You can switch back to Fahrenheit if you're more familiar with it, just to get kind of used to that range. For example, I told you 96.5 degrees Celsius may not mean very much to you, but you switch it to Fahrenheit, you're like, oh, that's very, very hot. So it's good to switch it back and forth. In essence, all objects that are above absolute zero or that are not a perfect black body, meaning that they're absorbing all energy, will have some type of energy from the movement of the atoms and the emission of energy. The hotter it is, the more energy that is being emitted. The colder it is, it emits less energy. And so this thermopile is going to scale it on how much energy, lot to not enough sort of energy. And so most objects on the Earth emit infrared energy, including you. You're a warm body, so hooray. You're going to be emitting energy, and so that energy can then be recorded. Interesting fact, if you can actually get so much energy inside of an object that it will start to glow red. And that means that the energy is starting to spill into the visible spectrum. So if you see like a red hot metal, or you see like, a blacksmith working on it or in a movie or something like that, it's starting to glow red. That's glowing red because it's actually so hot the energy is starting to expand out and hitting frequencies that the human eye can see. So there's my little quick overview of how the infrared thermometer works. Hope you enjoyed it, and I'll be back with another one.